Good evening, everyone. Let's start. We are already at 60. Okay, so the last time I think we completed the properties of. Okay, Harsh, just a minute. Okay, they didn't write it. Quite surprising. Okay, right. So we have covered all the properties of conductors in electrostatics, right? It is important to remember the properties. Okay, everyone, make sure you do remember all these properties, right? Now, uh, often a question on properties of conductors or about electrostatic shielding is asked in exam, right? I've seen that we get a question of electrostatic shielding, or we get a question of uh, the entire properties, right? All the properties. Now, in that case, suppose you get a question of all the properties, then you just write the heading, the main line. All right, that's it. Okay, don't need to explain the properties, because if you do, it will be a very long answer, right? I hope everyone understood what I said. If a question about making a list of properties is asked, or question something like write properties of conductors in electrostatics, then you write only the main sentence, that's it. All right, no need to explain anything, just make a list of all the properties, that's it. And then you can draw diagrams, right? uh, these diagrams are given in the textbook, right, at the end of this topic, right? I don't know page number, right? They're given at the end of this topic, all right, of properties of conductors. So you can draw those diagrams, right, and that will give you all the marks that you need. Okay, no need to explain all of it, right? If they ask only one, then you should explain, otherwise it's all right. But yes, these properties are very important. Okay, Khushi says page 70. We should take 2 lectures a day. Sorry, Avinash, not possible. Okay, so that's not going to happen, right? Uh, okay, now let's go to the next thing. Example 2.7 is for you to do on your own. All right, it's a theory based question. You can read it and you can understand it. If there's some problem, you can ask me. No, don't worry about that, right? But it is for you to do on your own. Now let's solve some questions from the exercise which are maybe connected with what we have done, right? So we're going to the exercise now. Okay. Hmm. Question number 4. Question number 4 from the exercise. Avinash, why are you concerned about all that? They are more than your class. That's it. Okay. So a spherical conductor, so it's a sphere of radius 12 centimeter, right? Has a charge of 1.6 into 10 raised to minus 7 coulomb, right? So draw a diagram. Come on, everyone. Draw a sphere. Radius is 12 centimeter. And the charge on that sphere is 1.6 into 10 raised to minus 17 coulomb distributed uniformly on its surface. Okay. So this is a sphere, and where's all the charge? It's on the surface, and it's a positive charge. Uniformly distributed on the surface like this. All right. Okay, now the question is, what is the electric field inside the sphere? All right. At this point, what's the electric field? Hurry up. Okay, I think that's good enough. 0, right? Because this is a conductor, you don't have to worry about anything, right? We have also studied this in first chapter, right? Okay, this whole question is actually from the first chapter because at every point they're asking for electric field, right? Okay, so I think I should leave it for you as homework. This is just outside. Just outside means very close to this surface, right? And at 18 centimeter from center. All right, so all this is homework, but because we are doing it, we will change this a little bit. All right, let's see how. Okay, time for some fun. Okay, shall we start now? You understood what I've changed? Instead of field, we are going to do it for potential. The original question is homework, everyone. You have to do it on your own. Okay. Right? So let's start with A. Potential, don't forget, potential at inside the sphere, over here anywhere, right? What is V? See, this is a conductor. What is the property of potential for a conductor? Do you remember that? What is the, it is equipotential, all right, but how much is that potential? How much is that potential? It is uniform everywhere, it's same everywhere, agreed. How much? No, Swarali, that's wrong. Sakshi, how much is it? Constant, understood. How much? Sigma by epsilon? No. Purvendra, that's wrong. That was electric field. Yes, some of you have already given the correct answer. Well, see, the potential inside is going to be same as at the surface, right? I hope you remember that. And at the surface, it's quite clear. See, the electric field at the surface is following kq by r square formula, right? And on the surface or outside, we just assume that all the charge is concentrated at the center. So you can just say that there is plus q charge here, and now this is the surface, right? And I want to find what's the potential at this point, right? Then I'll say just that v is equal to kq by capital R, because capital R is radius. Understood? Understood, right? Equal to surface, yes. So on surface, this is going to be, sorry, just a minute. On surface, this potential is going to be kq by capital R, because this is a sphere, don't forget. This is not true if this is not a uniform spherical conductor, right? Understood? Yes or no, everyone? Is this clear? So find the answer. What will it be? What will it be then? What will it be? Tell me the answer quickly. Krupa, will you please write the unit? Everyone, hurry up. Okay. Well, we are getting different answers now. Check your answers. Check your answers, people. No, no, no. We have got four different answers from four different people. Okay. Chaitya, right? Okay. Krishraj, noted what you said. Coulomb આવે સહદેવ unit coulomb આવે potential નું. Chaitya, your unit, the unit is also wrong. Okay, Darshi, you're getting a totally different answer. GIU2. Sakshi, your answer is also quite different from others. Rutva, are you sure about the power? And a volt, loko volt. Okay, Rutva, write volt. GIU to write volt. Okay, Surali, your answer is again different from everyone. ક્યાં જતા રહ્યા બાકીના 67 છે હજી 60 બાકી છે. Hurry up. ધ્યાન, unit. Deval, are you sure about the power? Omdeep, Newton per coulomb no આવે. ખુશી. Okay, Tanay. Arshad, your answer is different from everybody. Confirm, Darshi, sure. Okay, Sumit, no unit? All right, let me do it now. I think that's enough. Okay, sorry, over here. Yeah. So this is equal to 9 into 10 raised to 9. What's the charge? 1.6 10 raised to minus 7 divided by R, 12 centimeter. 12 centimeter, right? Yes. So 12 into 10 raised to minus 2. Okay, so this is 3 3 the 3 4 the, and this is 0.4. So 1.2 into 10 raised to 4 volt. Okay, that's it. I got the correct answer, and so many of you also got the correct answer. Well done. -8 નથી આવતું જય. -8 can be. Mega, what's the power? You didn't write the power. Okay, so that's it, right? So this is the answer of first. Let's go to second one. Hurry up. Hurry up, everybody. Second one. Hurry up, people. Just outside the sphere. Just outside the sphere means somewhere over here, very close to the surface, right? Just outside the sphere, very close to the surface. ઝૂમ માંથી હાથ કાઢીને ઉઠાડું. ઉઠો બધા જલ્દી હવે. ચા પીને બેસતા હોય તો એ છે 19 ક્યાંથી આવ્યો આમાં? Okay, very good. The answer will be same. That's correct. Yes, 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 correct. Just outside the sphere is same as the surface because just outside means very close to the surface. All right. Yes, the same as A. Now let's go to next. C. Okay. 18 centimeter from the center of sphere. Over here, maybe at this point, right? 18 centimeter. So, okay, everyone, just a minute. This is very simple. Let me just explain that. If there is a sphere and you want to find potential outside the sphere, then you just have to consider all the charge at the center, right? Consider charge concentrated at center, right? I think everyone understands that, right? So formula of V will become KQ by small r, right? This is for outside the sphere, right? Outside the sphere. Okay, what's the answer of this one? What's the answer of this one? Okay. 10 raised to 4 કે 3? ચૈત્ય બધાને 3 આવે તાર 4 આવે. All right. કોનું mic ચાલુ થયું? Can you please turn it off? Thank you. Right. તારે 4 આવે. Surbhi, you're getting a completely different answer. Sorali, you too. Kushi is also getting a totally different answer. Okay. They were different answer, completely different. Okay, let's do it. Let's do it. So here, minimize થાય તો કંઈક કરું ને. હા. I'm sorry, you can't see the screen. Zero no આવે રજત. Okay. K 9 into 10 raised to 9, 1.2 10 raised to minus 7 divided by, ના 1.2 નથી નહીં 1.6 divided by 18 centimeter. Okay, this is divided by 18 centimeter. So now of course this is cancelled. So આટલું જ થઈ ગયું ને હવે. So 0.8 into 10 raised to 10 raised to what? 4, correct? So that is 8 kilovolt or 8,000. All right. Okay. So that's it. Fine. બરાબર. રમ્ય correct answer. Volt લખવાનું ભૂલતા નહીં હો એક્ઝામમાં પાછા બધા. So that's it for this question. Let's find out next question that we could solve. So this is going to be capacitor. No, capacitor. No. Okay. We have done 12 and 13. Okay. 14. What about 14? હા લખાય. સાચું હોય તો લખાય. ચૈત્ય. 14. Okay, done. Right. So now we are going to solve 15. Okay. We are going to solve 15. Okay. So read the question. Actually, we can do the 14, but sorry, 15, but to do that, we'll have to prove something else first. Just a minute. Let me think about it. What's the easiest way to do it? Okay, fine. All right. Now we will stop with second chapter over here. We will go to first chapter. In the first chapter exercise, there were a couple of questions, a few questions which I told you we'll do it after we study second chapter, right? Now is the time to do those questions. So open the first chapter's exercise. All right. Okay, everyone open the first chapter's exercise. Mm, And please give me a minute to uh, take the question from the file. First chapter. Okay. All right. So now at the exercises, we are going to solve the question number 28 from first chapter's exercise. All right. From chapter 1. Question 28. All right. Now, why am I doing this? It will, this B part here actually helps me explain that question, right, from chapter 2. So first we'll do this and then we'll do that, right? So A, first of all, we start with A. So I'm reading it. A conductor A with a cavity is shown in figure. I hope you understand this is the cavity, right? Is given a charge Q. So this conductor, it has some random shape. Okay, it can be any shape, no problem, right? This has some random shape, right? And there is a charge Q on this conductor, right? Show that means prove that entire charge must appear on outer surface of conductor. We have already proven it, right? I hope you remember that. If you don't put anything inside, all the charge will appear over here. We have already proven that, right? I will just go through it very quickly, right, by using the following idea. At this place, this place, this place, or anywhere over here, right, at any point, anywhere over here, right, the electric field is definitely zero, and that's why I can take any Gaussian surface like I've shown, right? For any Gaussian surface, flux will be zero because there is no electric field anywhere inside a conductor. I hope that makes sense to you, right? And if flux is zero, then I can say that in any of these Gaussian surfaces, charge enclosed is zero, right? That means at any point inside the conductor, at any point inside the conductor, there is no excess or net charge, right? Okay, fine. Now that obviously makes us ask a simple question. Charge to आइपो दो, but the charge is nowhere inside, right? Charge is not at any point inside. So gyo kya? Tell me that. Can you answer that? If charge is not at any point inside, where is the charge that you have given? હું તમને 10 રૂપિયા આપું પછી તમે જો 10 રૂપિયા આ પોકેટમાં નથી, ઓલામાંય નથી, મોઢામાંય નથી, બૂટમાંય નથી, ક્યાં ગયા 10 રૂપિયા? ખાઈ ગયા? It is obviously on the outer surface, right? So proved. Okay, thus charge Q must be on outer surface. Okay, that's it. Now B part. Okay, see what I'll do is I'll just copy this whole question again, so that you can, I mean, I don't have to scroll it up and down again and again. Right, outer surface. Okay, that's right. આ ઓલી પ્રોપર્ટી છે ને, જો આ કેવા બેશરમ લોકો છે. ચેપ્ટર 1 માં ક્વેશ્ચન આપ્યો, એ ચેપ્ટર 2 માં પ્રોપર્ટી બનાવી. તો આપણે શું કામ મહેનત કરવી જોઈએ બે બે વાર. રાઈટ. બી, another conductor B with charge Q is inserted into the cavity keeping B insulated from A. Insulated means charge will not flow from B to A, right? B and A are insulated from each other, right? Means charge will not flow from B to A. Look at the figure. So what is given? There is a big conductor A, all right? Inside that there is a cavity. So this is a cavity. Now inside that cavity there is another small conductor B. Okay, A has a charge Q, right? That is given, right? એ તો પહેલા A પાર્ટમાં જ હતું ને, એમાં છે, right? A has a charge Q and B has a charge small q, right? So how much charge does B have? Small q. Okay, question is clear? Everybody say yes or no, then we will proceed. This is one conductor A, right? This is another conductor B, right? And they are given charges. No, not clear? અરે એવું વિચારો, there is one metal body, right? એની અંદર સ્પેસ છે, એની અંદર કેવિટી છે, એ કેવિટીની અંદર બીજું મેટલ મૂક્યું છે. ઓકે, right? And there is no connection, there is no wire between these two, so that charge will not flow, right? That's why it is written that they are insulated from each other. Okay, that is charge cannot go from this to that. What is Q plus Q written there? Himani prove કરવાનું છે આપણે. That is what they have written over there. We have to prove that the charge over there is Q plus Q. Okay, so don't be confused by that. Okay, show that, show means prove, right? So we have to prove something. What do we have to prove? Prove that total charge on outside surface of A is Q plus Q, right? So we have to prove that if you do this kind of thing, તમે આવી રીતે મૂકી દો, right? Suppose you put it like this, then what will happen is automatically over here a charge Q plus Q will come, right? Okay, again charge of this is not going there, it is insulated, meaning charge is not flowing like that. Okay, so we have to prove that the charge over here becomes Q plus Q. Okay, how do we prove it? Let's start. Okay, let's start everyone. So first of all, I want you to understand that if I take, listen to this carefully, if I take a Gaussian surface very close to this inner edge, you understand what I'm doing? I'm taking a Gaussian surface very close to this inner edge, right? So we take a Gaussian surface very close to the inner surface of A as shown in figure. Figure is very helpful. Figure વગર એટલું બધું વર્ડ્સમાં સમજાવો તો ક્યારે પેપર પૂરું થાય? Okay, is this step clear? This dotted is the Gaussian surface. Okay, fine. Right. Now I am going to ask you some easy questions. What is the electric field at this point? ખુશી ઇલેક્ટ્રિક ફિલ્ડ કેનોટ બી પોઝિટિવ. હવે આટલા બધા લોકોએ 0 0 0 0 કહી દીધું હો. હવે 0 કેવી રીતે આવે? 0 કેવી રીતે આવે? ઝીરો કેવી થયું? કેન યુ એક્સપ્લેન? ક્યાંથી લઈ આવ્યા તમે 0? Okay, Sakshi has a different answer. What is the question? The question is what is electric field here? That's the question. All right. No, Swarali, that's not the right answer. The simplest reason is that as each point of this surface, Gaussian surface, right? Whether it is here or here or here or here or here or anywhere, right? As each point of this Gaussian surface is in the body of conductor, yes or no? Body of conductor, right? I hope you realize that this part of conductor is solid. બરાબર ને? Okay, so it is in the body of conductor. In the body of conductor, what is the electric field? This is the correct reason. There is no other correct reason. All right, there is no other correct reason. So guessing will not work. જો તમને આ reason ખબર હોય તો સાચું. Then you can think that I am congratulating you. Otherwise, not. Okay. No, Harsh, your answer is wrong. No, Tanay. Okay, so everyone check your answers. Did you really think like this? Okay, then if electric field at all these points is 0, then for Gaussian surface, flux is also 0. બરાબર ને? Because there is no field, there is no flux. But if we use Gauss law, okay, now we use Gauss law. Okay, so by the Gauss law, I can write sigma q enclosed is equal to 0, right? Because flux is 0, so sigma q enclosed should also be 0. But we have a problem. Look at this diagram. Look at this diagram. Here there is a charge q. So I hope you realize that total charge enclosed is 0 by the Gaussian surface only if on this inside surface, okay, inner surface, charge on the inner surface must be equal to minus q. Did you understand this? Okay, I will explain. All right, let me just explain it again. Suppose here the charge is x on this inner surface, okay, over here on this inner surface, over here. All right, the total charge on this inner surface is how much? X. Okay, let's say it is x. Then by this idea you should have q plus x equal to 0. Agreed? Because all that charge is inside the green dotted Gaussian surface, right? See, it is inside this Gaussian surface. Correct? So sigma q enclosed for the Gaussian surface is nothing but x plus q. All right, but that is equal to 0. So x plus q is equal to 0. Therefore x is equal to minus q. What does that mean? On inner surface of A, there is charge minus q. Okay, say yes or no about this one. If you have questions, please write it in the chat box. Okay, please write it in the chat box if you have a question. Okay. See, now we go to the next step. Total charge on A is Q, isn't it? We have given it a charge capital Q, right? Okay. But charge on inner surface is minus small q. Now think about this very carefully. This is inner surface, outer surface. Inner surface minus q. How much should be the charge? I repeat, what should be the charge here, over here on this outer surface? What should be the charge, right? So that total charge becomes q. Rutva, that charge was induced, right? Because we put that small q inside, it attracted the electrons, and electrons settled on the inner surface, right? Okay, I hope it's clear, Rutva. Yes, Shivangi, yes. In short, you can say charge minus q is induced. Correct. Okay, well done, people. Some of you have given right answer. See, it's quite simple. Suppose you call this here unknown charge y, okay, and this is minus q. Now total charge is q, so that should be equal to y plus minus q, right? I don't think anyone has a problem with that. Okay, so how much is y? Done, right? So that means charge, everyone. Okay, can you all hear me? All right, fine. I'm sorry, there was a internet connection problem. All right, uh, I hope now you can see the screen also. All right, so I was saying that charge on outer surface is q plus q. Proved, right? This is what we want to prove. Okay, so you know what has happened over here. Let me explain the whole story in words. What has happened is as follows. Okay, I'll just draw a new diagram that will help. So suppose this is that conductor A, all right? Okay, and this is the cavity in it, and now here is that conductor B. So when you put this inside, right? When you put this q inside, what happens is it attracts. Suppose this is positive, right? And opposite explanation will work for negative. Suppose q is positive, then what it will do is it will attract the free electrons from the conductor and make them settle over here, right? Okay, so that will make a total negative charge on inner surface, right? So how much negative charge is induced on the inner surface? Again, you could say induced, that's the correct word. Induced negative charge on inner surface is minus q. Okay, so here on this inner surface we get a total charge minus q. Okay, but because this A had total charge capital Q, so કેના જેવું છે જો આ બે સાઈડ થઈ, right? Suppose total is 10. If it's 5 here, it will be 5 here, right? Suppose total is 10, but this is 7 here, then the total over here will be 3, right? Just like that, if it is minus 3 on this side, suppose total is 10 and this is minus 3, how much will be over here? How did it will be 13. Clear? Okay, did you understand this? So because total charge on A is capital Q, that's why remaining charge is on outer surface, right? So what's the charge on outer surface, right? That will be Q plus Q. Yes, A and B are insulated, agreed. See, charge is not flowing. Remember, what is induction? Yachane, what is induction? Induction is like magic, isn't it? I hope everyone remembers that. Induction means without touching, right? So what this B has done is it has attracted electrons, and now there is a charge minus Q here, right? And that's why there is a charge Q plus Q here. Okay, can someone answer this easy question? What's the total charge on A? What's the total charge on A? I'll answer it, right? It's that simple. I don't want you to take trouble. It is Q, correct? Pella કેટલો હતો? This is total charge in B. What was the total charge in part A of the question? What was the total charge on A in part A of the question? That was also Q, right? So you see, A's charge has not changed. Only distribution has changed. What do I mean by distribution? Do you understand what I'm saying? Only the distribution has changed, right? Okay. This is a room, all right, and here 3 boxes are placed, okay, and over here no box is placed, 0 boxes. તો અહીંથી એક ઉપાડીને અહીંયા મૂકી દો તો બોક્સ વધી ગયા? No. Now this is 2 plus 1. That is what has happened. Understood this whole idea? Yes, rearrangement. Correct, Swarali. You could also say it is rearrangement. Okay. No, KR, total charge on A is only capital Q. Let's see how. Charge on outer surface is Q plus Q, right? And on inner surface is minus Q. So, કેટલો થાય total? Outer surface Q plus Q, inner surface minus Q. How much is the total? Q, right? You know, there might be a confusion about words here. When we say charge on A, આનો મતલબ થાય total charge held or possessed by A. બરાબર ને? Is that okay? Right? This is different from charge on surface, right? This is different from charge on surface. I hope nobody is getting confused by all these, right? Okay, just that we will summarize this. Sorry, the whole class went away in just one question over here. I'm so sorry for that. It's just that, listen to this carefully. Even if you have any shape thing here, okay, quick question to understand whether to check whether you know what I have taught you, right? Suppose this is a conductor, all right, okay, this is a conductor, right, and here I put plus 3 coulomb charge, okay, right, and let's say this is neutral conductor, all right, let's say this is neutral conductor. Then you have to tell me what is the charge on inner and outer surface. Come on everyone, what is the charge on inner and outer surface? Hurry up everybody, simple question. Hurry up, come on. Unit lock, Krupa. And this is answer for what? Yes. Okay, very good, Surali, well done. No, Sakshi, wrong answer. No, KR, wrong answer. Tanay, you are writing answer for which question? Yes, Christy, correct answer. Correct answer, Chaitya, well done. Avinash, your answer is also right. Jia, it's wrong. Yes, KR, now it's right. બસ પતી ગયા બધા, આટલા જ છે. જલ્દી કરો, જલ્દી કરો. Hurry up, people. No, Vishwas, wrong answer. No, Kushi, wrong answer. Krupa, it's wrong. Read it again. What have you written? Hurry up, everyone. અરે 10 આન્સર જ આવ્યા છે હજી. Hurry up, hurry up. આટલા બધા છે, બાકીના 50 ક્યાં ગયા? कुछ तो गड़बड़ है કે આટલા બધાને ખોટા આવ્યા એટલે હવે તમારી હિંમત નથી થતી. નો, વિશ્વા, નોટ ધ રાઈટ આન્સર. દર્શી, નોટ કરેક્ટ. યસ, સાક્ષી, નાવ ઇટ્સ રાઈટ. નો, દેવલ. Arshad, it's right. Well done. Omdeep, which answer is that? No, Darshi. No, no, no. Yes. Shivangi, it's wrong. Kea, it's correct. અરે શું કરો છો બધા? કેમ એટલા કન્ફ્યુઝ થઈ ગયા? Okay, enough of answers. I don't want anything now. Enough of answers. See, this is a positive charge. So look at what we derived earlier. It's that if you put Q here, then you get minus Q here, correct? So if I put plus 3 coulomb here, I will obviously get minus 3 coulomb on inner surface. Take your answer. What happened, Dhyan? Okay, so you'll get minus, oh, okay, just a minute. You'll get minus 3 coulomb on inner surface, all right? But see, this whole thing is neutral. This conductor is neutral. So અહીંયા minus 3 આવ્યો તો અહીંયા કેટલો આવવો જોઈએ? To make total 0, don't forget. To make total 0. 0 કેમ? Neutral. All right? So outer should be plus 3 coulomb. Understood? Everybody? ના વિવેક, 0 નો આવે. હવે કન્ફ્યુઝન નહીં થાય ને? Okay. All right. Try this now. પણ હું બોલતો જ નથી રમ્યા, હું તો શાંતિથી ક્વેશ્ચન લખતો. Okay, this is your question. So there are 4 answers. Okay, let's call this inner shell A. Sorry, yeah, and this outer shell, larger shell B. Okay, એટલે બરાબર તમને ખબર પડે. ચૈત્ય 4 આન્સર છે, 4 આન્સર આપો. 2 નહીં, 4. ફિગર ડ્રો કરજો પહેલા, નહીતર કઈ ટપ્પો પડવાનો નથી. ડ્રો ધ ફિગર, everyone. 4 આન્સર જોઈએ ચૈત્ય, 2 નો જોઈએ, 4 જોઈએ. હજી કહું છું તને. So please write your answers as follows: A inner, A outer, B inner and B outer. बराबर? चार answer आएगा. Do it like that. Yes, Rutva, what happened? Okay, Purvendra, you got first one right. ચૈત્ય તો હવે એ બી નહીં લખ ને તો તને કાઢી મૂકી દો મીટિંગ માંથી. Yes, Devanshi, well done. No, Sakshi, think about it carefully. Both are conductors. A1 શું છે? Inner. No, wrong. Okay, Devanshi, correct. Okay, I will show you the question. Don't worry. Just a minute. Okay, here. Swarali, if A inner is 3Q, A outer is also 3Q, then wouldn't total become 6Q? Okay, Purvendra, B inner, correct answer. No, Shivangi, think about it. No, Chaitya, wrong answer. Yes, Purvendra, well done. You finished the whole problem first. Yes, Devanshi, right. B inner is right for you. B outer is also right. Very good. Omdeep, is that right? Yes. A outer should be that. Okay. Done all four, Chaitya, but all are wrong. Do it again. Okay, એટલા બધા લોકો આન્સર આપી દીધો. I'm sorry, I was very slow in reading. Okay, let's discuss. First of all, diagram. So this is the shell B, અહીંયા A. See, these are shells, all right? Okay, first of all, see, both of these are conductors, right? Inside a conductor surface, if you give a charge to a conductor, where will all that charge go? On the outer surface, correct? Right? Because, and that will happen with A only, because inside A there is nothing, right? I hope you understand. Inside A there is nothing. So that's why the answer of this first one, inner charge on A, is 0. Clear? અહીંયા સૌથી મોટી તકલીફ પડે, બીજું તો બધું કઈ છે નહીં ખાસ. Clear or not clear? Yes or no? Hurry up, people. Hurry up. Is this right? Yes or no? Did you understand? Because there is nothing inside it, right? And you know, charge repels, right? So on a conductor, if this is a conductor and you give it some charge, where will all the charge go? All the charge will go on the outer surface, correct or not? Because there is nothing to hold it inside. અહીંયા કઈ છે જ નહીં, right? If I put a small charge Q here, then it will be a different story, right? તો આખો question બદલાઈ જશે, બધું ફરીવાર કરવું પડે, right? But like I said, there is nothing over here. Okay. So charge will go on outer surface of A. So here this will, okay, yeah, so here this will be 3Q, right? 3Q જતું ને? હા, 3Q. Clear? Because the total should be 3Q. For A, total should be 3Q, right? Okay. So now what we have found out is as follows. It is 0 here. It is 3Q here. બરાબર? હવે હજી આગળ, હવે અહીંયા B inner. B inner. Okay. No, Dhyan, not minus Q. See, this is This is like the question that we just solved. અહીંયા 3q છે ને, તો આ સરફેસ પર -3q આવવો જોઈએ. As simple as that. Clear or not clear? What about this? Yes or no? So if there is -q total, right? B's total is minus q. So that's why there will be 2q on this outer one, right? Okay, let me just explain why it should be like this. See, everyone, listen to this carefully. Okay, listen to this very carefully. Whatever this shell is, right, it will definitely have some small or negligible thickness, right? So I'm drawing shell B. Okay, right? And if we take a Gaussian surface just inside this thing here, over here, close to this inside surface, જેવી રીતે આપણે ઓલો first chapter નો question solve કર્યો હતો એવું જ, so in that case here electric field is 0. Because electric field is 0, flux is 0, and that would mean charge enclosed will also be 0. પણ અહીંયા તો વચ્ચે આખું ઓલું છે જેનો ચાર્જ 3q છે, right? So how much charge should be on this surface? It should be 3q plus unknown equal to 0, correct? So this unknown has to be equal to -3. Take you proof. I hope everyone understood this proof also, right? So that's how we get this -3q. Now if you get -3q here and this is total -q, so this should be 2q, right? આ તમારો નીટ જેડબલી લેવલ જેવો સમ હતો. ઓકે, બેમાં આવે છે આવું. ઓલરાઈટ, ખાલી ચાર્જ નો ફાઇન્ડ કરવાનો હોય, પછી પોટેન્શિયલ ફાઇન્ડ કરવાનો, રાઈટ? એ હવે અત્યારે નહીં. ઓલરાઈટ, મારે તમને થોડુંક હોમવર્ક આપવું છે, તમને સ્કૂલમાંથી તો આપ્યું જ છે. ઓકે, વોટ આઈ એમ ગિવિંગ ઇઝ એક્સ્ટ્રા. એ કરી નાખજો પૂરું જાતે જાતે. Go to the exercise of chapter 2. Jaldi karjo. Go to the exercise of chapter 2, and over there question number 21 and 22 are homework. Question 21 and 22 are homework. Okay, right, let me just write it once again. 21 and 22 from chapter 2. All right, chalo, goodbye everyone.